I will introduce Alibaba Cloud Native solution for you. The content include industry trending and challenge, container service portfolio, deep dive for container service. Finally, I will show you some use cases. As we can see the evolutionary path from virtualization to infrastructure as code to containers to serverless. So now we are in containers and serverless era. By 2022, more than 75% of global organizations will be running containerized applications in production. So we know in the further few years, cloud-native applications will become the norm. Actually, there have some common challenges during cloud-native transformation. How to use elasticity to saving cost and increase resource utilization. How to use serverless cluster running applications when boosting workloads. How to monitor Kubernetes cluster, easy analysis application log, and observe cluster event in a centralized event center. Currently, have more and more enterprise using hybrid cloud and multi-cloud. How to easy management hybrid cloud or multi-cloud environment. Above challenges can be solved. Let's take a look at the solution. First of all, let's see container service portfolio. We provide two methods, ACK and ASK. The short named by Alibaba Cloud Container Service for Kubernetes and Alibaba Cloud Serverless Kubernetes Service. ACK and ASK seamlessly integrated with Alibaba Cloud products. Make you easy to use Kubernetes cluster on Alibaba Cloud. And ACK and ASK, they integrated with computing, network, and storage. You could create ECS, EBM, ECI as Kubernetes worker node. You could create a Kubernetes cluster in a VPC, define IP range with vSwitch, assign port IP from ENI, export service by SLB. All kinds of storage you could using as Kubernetes persistent volume. The storage include EBS, NAS, CPFS, and OSS. Upon ACK and ASK, we provide security to make your Kubernetes cluster and application runtime be secure. Observability to make you easy observe your Kubernetes cluster and monitor your application. For elasticity, we make you easy scale up or scale down your Kubernetes cluster. We also have multi-cloud and hybrid cloud management solution. If you want to use Istio or Knative, you could easily install add-on from console. Or when you create an ASK, you could directly deploy Knative serving on ASK without install any component. Sandbox containers, which is container running engine. It provides isolation container runtime. ACR, which is container registry. It can store Docker image and Helm chart. ASM, which is manage the service mesh. It makes you easy using service mesh without install and configure anything. Based on those abilities, all kinds of applications can be running on ACK and ASK, such as microservice application, stateful middleware, even big data and AI, blockchain, and IoT. So you could using ACK, ASK directly from public cloud, or they can deploy in private cloud, or they can running on edge computing. This is the newest report from Gartner this year. They are competitive Alibaba, AWS, Google, IBM, Microsoft, and Oracle. Analysis from 6 criteria. So we can see ACK have rich products technique layout. We summarize the ACK advantage with 4 points. The first one is rich products. ACK have managed and dedicated cluster are available in 19 regions. ASK, which is a serverless container running on elastic container instance. ASM, which is Istio-based managed service mesh. ACR, which is private container registry. It can automatically synchronize images cross-region in worldwide. Includes image scanning with delivery chain. We also have hybrid cloud and multi-cloud solution. Allows you to manage external Kubernetes cluster outside Alibaba Cloud. The second one is large-scale practice. ACK used by Alibaba Group's large e-commerce platform Double 11. This demonstrates the robustness of ACK technologies. The third one is extremely elasticity. Application can be simply auto-scale in second. Scale up 500 nodes, take 2.5 in standard mode. Take 90 seconds in Swift mode. Just take 30 seconds on ECI. Supports HPA, Cron HPA, VPA with multiple dimension external metrics rather than only scale by CPU and memory metrics. Container running on elastic bare metal improve performance by 20% than physical machine. Double 11 is the world's largest online shopping level festival from Alibaba Group. We have 2 million containers running on elastic bare metal. We also have cloud-native database we call PoloDB. It provides great performance. It can store 100 TB data and so million QPS. For applications reliability, we leverage extreme elasticity and to add stress testing, flow control, graceful degradation, monitoring, and notifying to achieve peak order creation per second of 544,000. For DevOps efficiency, we have accelerated image distribution over than 10,000 nodes to make pooling image be stable and faster in large cluster. For security part, it can protect attacks from internet. It also can detect risk from inside container. We also have much more innovation from big data and AI, and which is running on container as well to increase resource utilization. We are the member in some open source community. We are initiative member of Open Application Model. Application team member elected as a member of CNCF Technical Oversight Committee. Next, let's go through deep dive for container service. When we create a cluster, have multi-templates we can choose. The standard managed cluster or heterogeneous computing cluster, elastic bare-metal cluster, edge cluster, Windows cluster, or standard dedicated cluster, dedicated heterogeneous cluster, or serverless cluster, or confidential computing cluster. So what's the difference of dedicated, managed, and serverless cluster? For dedicated Kubernetes, the master node and the worker node are managed by user. The managed Kubernetes cluster, the master node is managed by Alibaba Cloud, and the worker node is managed by user. For serverless Kubernetes cluster, the master node and the worker node are managed by Alibaba Cloud side. For managed and dedicated Kubernetes cluster, we can see the pod running on ECS or elastic bare-metal, but it can simply scale up to ECI. The scenario for application keep persistent running. It supports spot instance, GPU, FPGA instance. For serverless Kubernetes, we can see the pod running on ECI elastic container instance. The scenario for the application, which is temporary running, for example, data processing, CI/CD pipeline, or GitLab runner. It also supports spot instance and GPU instance. ACR, which is Container Registry Service. It can manage both Docker image and Helm chart. It provides end-to-end security, allow you pulling image with VPC internal endpoint, and you can define domain and network ACL. It also can scan vulnerability during build image. So it has accelerated image distribution based on P2P technology in large cluster to make pooling image be stable. It also has image replication across different regions in worldwide. For storage, all kinds of application storage can be using with Kubernetes persistent volume. Each storage fitting for different scenario. The cloud disk is good for stateful application database. The NAS is fitting for log shared data. OSS is good for media genetic data. CPFS is good for HPC deep learning. Local disk is fitting for database and Hadoop. And all kinds of storage is support end-to-end encryption with customer master key and bring your own key. Cloud disk and local disk support online resizing, and metrics can be monitored. For OSS, we support distribution cache acceleration for machine learning. For network, we provide two types of network, Flynode and Turvey. The Flynode is easy to use. Pod leverage VPC to communication. Turvey support network policy, and performance is better than Flynode. In the Turvey network, the pod connection with ENI, Elastic Network Interface. Turvey is implemented by Alibaba Cloud. It also supports exclusive ENI mode. In that mode, the network performance do not have any consumption. For security, we provide end-to-end cloud-native security. In infrastructure layer, we support fine-grained algorithm for pod. For software layer, we provide image scanning and image signing DevSecOps to make software be secure during supply chain. For runtime layer, we provide network policy, KMS, runtime defense to protect application runtime be secure. For elasticity, we provide two-level scaling, resource scaling, and application scaling. For resource scaling, it can be scaled up or scaled down ECS, EVM, GPU-based instance, spot instance, or virtual node. For application scaling, we support HPA, VPA, and cron HPA. For HPA part, it can be triggered by external metrics, such as QPS, website latency, etc. Observability. We know in observability have three pillars. Alibaba Cloud have some services mapping for logging, metrics, and tracing. All those services are seamlessly integrated with ACA as well to make you easy observe your Kubernetes cluster and monitor your application. For AI and big data scenario, we provide heterogeneous computing, make you simply build CPU, GPU, FPGA, RDMA, and storage for machine learning and big data fundamental environment. Support major machine learning framework such as TensorFlow, MXNet, Caffe, etc. based on Kubeflow. For increased resource utilization, we optimize the Kubernetes scheduling strategy to make pods be tight on GPU node. We also have shared GPU ability, and we provide GPU isolated. We also provide core scheduling and capacity scheduling strategy, and the core scheduling developed by Alibaba Cloud and contributed to community. The GPU and shared GPU utilization can be monitored in Prometheus. On top of that, we provide our Arena, which is command line tools to make it easy to run machine learning job. Arena initial developed by Alibaba Cloud and contributed to Kubeflow. Hybrid cloud and multi-cloud strategy. From our experience, the three types of solutions are popular. The first one is active-active. The multi-cluster running on cloud and IDC, respectively, and leverage federation to manage the multi-cluster. CI/CD platform deploy application to multi-cluster and using GTM to manage global traffic. The second one is autoscale to Alibaba Cloud, the major application running on IDC. When the application needs scale, it can autoscale into Alibaba Cloud. Both services is registered to the same microservice registration and discovery. The third one is ACA multi-cloud management. Kubernetes cluster in IDC or other cloud provider can be registered to ACA. ACA multi-cloud management be able to manage cluster as the same as ACA cluster. The register cluster could be using log service or ARMS Prometheus to log in and monitoring the cluster or application. This is an example for cloud-native HA application architect. The Kubernetes cluster deployed in multi-zone using PolyDB as database, leverage log service, ARMS Prometheus, and ARMS to observe application and Kubernetes cluster. Next, I will show you some use case. This is a part of our customer around the world, like Siemens, Olympic, Temenos, Dana, or Investry. This customer was built Alibaba Cloud service with everything as code. The red color is created by Terraform. The blue color is created by Helm-chart. So everything as code reduce operation time and avoid error happened by human careless. This customer is running microservice on Alibaba Cloud. So the microservice is running on ACK and expose API through API gateway using WAF, anti-DDoS to protect website. Some files stored in OSS, also using log service, ARMS Prometheus to observe Kubernetes cluster and monitoring application. This customer is from monolith to microservices. The microservice deployed on ACK and some file stored in OSS using Redis, MySQL, PolyDB, AnalyticDB to store data and analysis data. The service can be accessed by website and mobile application. The customer side, by leveraging the solution proposed by Alibaba Cloud, we completed the re-architecture from monolith to microservices, shortened its time of app development and deployment, reduced IT and resource expenditure, and improve reliability and agility. This customer built AIoT on Alibaba Cloud, from collect sensor data to transfer data to data management to build a data middle layer, expose machine learning model through API gateway, some services running on ACK. Above content is about Alibaba Cloud native solution. We talk about Alibaba Cloud Container Service portfolio, Cloud Native Storage, Cloud Native Network, Cloud Native Security, Auto-scaling strategy, end-to-end observability, Cloud Native AI and Big Data, hybrid cloud, multi-cloud solution. So thank you for your time. Thank you for attending this session.
Hello, everyone. My name is Wei Zhang. I'm from Alibaba Cloud Container Service team. Today, I'm glad to share service Kubernetes. It will include service container introduction, the architecture, and several common use cases. Okay, let's start. The first part is the introduction of service container. Nowadays, everyone talk about service in public cloud. We all know the function computing like AWS Lambda. We can see that developers love service mostly. The reason of that is, I think, is service make developer the life be much easier. We think the reason contains three aspects. The first is the engine development. In service way, developers don't need to purchase a service, no need to provision service, no need to manage backend service. All need to do is just one run workload, and they don't need to upgrade the operating system and the system software. We can saw that the productivity is become much high, and the time to market of the application is much shorter. The second reason is scaling. We think in service way, the scaling is inherently scalable. Application built on with service infrastructure will scale automatically as the user growth and usage increase. From a developer point of view, the capacity can be unlimited. So scaling in service architecture is much simple. The third reason is cost saving. In service architecture, there is no need to maintain fixed resource pool. It's pay by demand. Charges start when workload start, charges end when workload ends. We will never pay for the idle resource. We found cost may saving up by 70% when we change the application architecture to service. In this section, our topic is service container. Service container is one kind of service architecture. It have all advantages of service architecture, engine development, easy to scale, and cost saving. Beside of these advantages, it's based on container, not function or any other form. Container make our application build once and run anywhere. There is no limitation on language and library. We can choose whatever language or library we want to build our application. And the most important part is the ecosystem. The whole cloud native and the Kubernetes ecosystem is built on container. We can benefit from enormous Helm charts, ISO Knative and many other Kubernetes framework. We don't need to worry about vendor lock-in because all this is built on top of containers. Today, most all public cloud providers have its own service container service available. This is the product landscape of public cloud. In service container catalog, Alibaba Cloud has a service Kubernetes and elastic container instance. AWS have Fargate, and based on Fargate, they have EKS on Fargate and ECS on Fargate. Azure has ACI, Azure Container Instance. Next, we will deep dive into our service container products, ECI, ACK on ECI, and ASK. ECI means Elastic Container Instance. It simply means we can create a container without managing loads and infrastructure. Before ECI, we have to purchase a ECS virtual machine to deploy a container. With ECI, no ECS purchasing and provision is needed. A container is the first-class citizen in public cloud. Each ECI is completely isolated, runs in a sandbox execution environment. The CPU is ranged from 25 to 64, and the support GPU instance. All this is paid by on demand. Using Spot instance, we can save cost mostly by 19%. ECI startup time is about 10 seconds. With image cache, image pooling time also can be saved. It was to mind that ECI and ECS share the same ICE resource pool. This can guarantee the enough underlying resources provided to ECI users. Standalone ECI is just like a single pod in Kubernetes cluster. If we want to use deployment with multiple replicas or stateful set or jobs or cron jobs, we shall use Kubernetes on ECI. At Alibaba Cloud, based on ECI, we have flexible ways to collect Kubernetes with ECI. The first one is use ECI pod in classical Kubernetes cluster. The second one is serverless Kubernetes. We call it as ACA. In ACA cluster, all pod is ECI instance. There is no node needed to manage. It's complete nodeless architecture. In ACK on ECI architecture, normal pod and ECI coexist in one cluster. Normally, user can put a non-run workload on ECS node and put a short-run or scaled workload on ECI. This way can optimize total cost efficiently. The Kubernetes cluster capacity is determined by the number of nodes in cluster. By adding ECI into cluster, the capacity of cluster becomes unlimited. It makes scaling be much more easier because users don't need to worry about the capacity planning. In this kind of hybrid cluster, ECI pod and ECS pod can be interconnected. It means ECI it is easy to communicate with ECS pod. It also supports cluster IP service. In this way, ECI pod is just like a normal pod. In serverless Kubernetes cluster, they have no node need to manage. User can just run the container application without managing the infrastructure. It's quite easy to use. In SK, we will never see the common issue of nodes. For example, node not ready is not exist in SK cluster. In other way, SK make Kubernetes much easier for end user. The scaling in SK is very fast based on ECI. It is compatible with the Kubernetes API like deployment, step set, job, service, ingress, and CID, and any other operators. We can also install Helm chart. The pod can be mounted disk, NAS, or OSS worms. In SK, we provide knative serving and elastic workload functionalities. We will expand this more later. SK also integrated well with ARMS and SLS products. It's easy to monitor the pod and dump the pod logs into SLS. This is the architecture of serverless Kubernetes. As we can see, the central part is SK scheduler. It is responsible for watch pod changes and then schedule the pod by calling ECI API to create an ECI instance. Then SK scheduler sync the ECI instance status back to pod. Using this nodeless architecture, we separated Kubernetes layer and ECI resource layer. This makes it ideal for elastic scaling in public cloud. In next part, we will show some basic functionalities to use ECI pod in serverless Kubernetes. It's quite easy to create a GPU instance. GPU driver is pre-installed, such as TensorFlow and CUDA toolkit. We can just configure the GPU spec in annotation and a number of GPU, then the GPU instance is created. ECI GPU instance share the same specs as ECS GPU. Spot instance is normally called a permittable instance. It means the pod can be permittable after 1 hour execution time based on a stock situation. Spot instance can minimize the cost in many scenarios, such as big data, image, and media coding, science computing, scalable website, and test. Such as same as ECS spot instance, we both spot as price goal and spot with price limit strategy. With the last workload, we can manage the replicas distribution of ECI on demand and support instance in one deployment. This can save cost for deployment or stateful set workload. In this YAML example, deployment engines will have 2 replicas runs in normal ECI on demand, and the rest 4 replicas runs as support ECI. Recently, ACA have managed CloudNative serving functionality. It provides automatic scanning. When the pod have low traffic, it will scale the minimal instance with lowest cost. When traffic becomes normal, pod will scale to normal instance. More CloudNative serving functionality is also supported in ACA. Okay, the final part that we see some common use case of serverless Kubernetes. Weibo is the largest social media company in China. It's just like Twitter in the United States. It could have unpredictable hot events, which bring hundreds of times of traffic in a short period of time. In order to handle this kind of peak traffic, using ECS scanning normally at least needs 5 limits, but using ACK and ECI, Weibo reduced the scanning time by 70%. It can scale 1,000 pods in 1 minute and scale to 0 when there is no traffic. Similarly with Weibo, many e-commerce and online education companies use ACK on ECI to handle peak traffic. When peak traffic comes, just scale workload on ECI. So there is no need to maintain large amounts of ECS nodes in Kubernetes cluster. Big data computing is also common use case for ACK. We can schedule Spark work jobs on ECI. There is no need to vary the cluster capacity by this way. Today, many users use ACK for CI/CD pipeline. Users schedule Jenkins and GitLab run jobs in ACK cluster. The total cost is much lower than using a classic Kubernetes cluster because the job is paid for on demand, not the loads. Okay, here I have some links for quick start. Try ACK and ECI is very simple. Just need 2 steps. First is create a service Kubernetes cluster. Second is create pod in that cluster. Okay, this is all my slides of this section. Welcome to try service container and the service Kubernetes in Alibaba Cloud. Hello everyone. Here is a demo of service Kubernetes. In this demo, we will show how to create a service cluster and show how to create a pod in service cluster. This is our ACK container. We can create a normal ACK cluster in this web container. Also, we can create a service cluster in here. Create a service cluster is very simple. First, we give a name. We just name it service. We choose a region. The next is we choose Kubernetes version. And next is VPC. We can create a new VPC or use existing VPC. We choose the zone. Network gateway means when we enable gateway. So if our pod, there is no need to access the internet. We just disable this one. Public access means if we want to access the web API server from the internet, so we need to expose the API server with the EIP. The private zone means service discovery in cluster. It's just similar with CloudNative in ACK cluster. If we just run a simple job, there is no need to use service discovery, so we also don't need Python in here. Okay, then we agree the terms. The next is create a cluster. So as we can see, create a service cluster is very, very simple. There is no need to purchasing or provision any nodes or works. They just give a name, choose region, and create a cluster. Okay, so it will take about 1 minute or less time to create a service cluster. And it was to mind that service cluster can be totally free. We don't, there is no charge or fee if we don't choose enable net gateway or public access. So it's totally free. It only charges when we create a pod in service cluster. Okay, let's get back. Which is initialize status. We want to wait for this service cluster. We just use a existing 100 region ACA cluster. We can copy the kube-config into SSH terminal. As we can see, Kubernetes cluster. In normal Kubernetes cluster, they must have a load before running any pod. So, but in service cluster, we just run our pod. We don't need to care about the underlying nodes. The first demo is just let's run a simple YAML file. In this YAML file, it contains a service and a deployment. The replicas of this deployment is 2. And it's quite simple. It's just the Nginx image. Apply it. Okay. Get pod. As you can see, the pod is assigned to a virtual Kubernetes node. It becomes running. Status. Another is pending. Okay, both is become running. And we check the nodes again. Currently, they have one virtual Kubernetes node. So this backseat shows us we first have pod, then they have a virtual node. Let's look at the service. We create. Okay, this is quite a simple demo. Let me delete it. No. Okay, we then can scale this deployment. We scale to 10. Okay, we also can check this pod in web console. And here, we get into the cluster and check the workload. The pods, they all become running. They have 2 loads in this cluster. Okay, we will clear up the resources. The next demo is Spot instance. Check. The YAML file is still very simple. it is a deployment with replicas 2, and we set the specs is 2 and 4 gigabyte. We use spot strategy as a price goal. It means we don't set the price limits, so it's a total price as a market flows. Okay, the 2 replicas is becoming running. Actually, this 2 pod instance is spot instance is not on demand. So basically, the cost of this spot instance is very low. So spot instance, we suggest it can be used in many scenarios like jobs, CI/CD, or Spark, Presto, or big data computing in many cases. The next demo is we can install a Helm chart. We just call Elastic workload. Just create it. It's very simple. Okay, I have we need to clean it. Okay, let's quit again. The Elastic workload controller is in pending status. It's coming running. Okay. Then we will create an Elastic workload object in this cluster. Let us first check the YAML file. In this YAML file, it's very simple. First is a basic deployment definition. It is quite normal. And we define a new Elastic workload object. It have reference to the engine's deployment. The minimal replicas is 0 and the maximal is 2. And the total Elastic workload replicas is 6. And they have a Elastic unit, ECI spot. In this unit, all pods have a rotation with spot as price goal. It means in this Elastic unit, all pod is spot. And they have a basic 2 replicas is normal ECI pod. Let's quit it. Okay. Let's clean up before engines spot. As we can see, they have 2 ECI normal pod and 4 ECI spot instance. We can scale the Elastic workload. We can scale it scale Elastic workload to 10. Okay, the spot instance have 8 replicas. We can scale down to 1. Okay, it's just one normal ECI pod. We scale back to 6. Okay, they have 4 ECI spot. This is a demo of Elastic workload. Besides of these demos, we can also easily to run Spark jobs in service cluster. The Helm chart installation is very simple. Okay, sorry. We logged in again. We change it to English. We quit again. After we install Spark Helm chart, we can create Spark jobs like this one. Okay. Back to our console. This is a demo of service Kubernetes cluster. As you can see, it's quite simple, and welcome to try it. Thank you for the time to watch this demo. Thank you.
Okay, I hope you all enjoyed the second session of today's training. We will have a 10 minutes break. Now it's 10:52 and we'll be back around 11 or 11:02. So I will see you at 11:02.